Hi, and welcome to another old steam-powered machine shop. If you're new to this channel, this is a shop that I put together to replicate a approximately 1925 job machine shop that runs on steam power. And I do general machine work in here for hire under steam power. Although I've been extremely busy in the front shop with a lot of work that got kind of piled up over the winter. And I got to get a lot of that out before we get back to the really good, fun steam stuff to do. The boiler, however, is inspected, and the internal inspection was done a few weeks ago and had no issues. I have some clips of a few things getting the boiler ready to put water in it and steam it up, but I haven't done it yet because I didn't want it to sit around with fresh water in it. So I'll fill the boiler when I get ready to run it. On the front shop, I have some cylinder heads I'll show you, and some motorcycle engine cylinders, a Kohler engine block, and a couple other things. And next video I will be getting back to the old work. And so I hope you'll stick with me on it. Thanks for watching, and we'll get to it. The injectors go back on. This is the Hancock. These are the water supply lines to the injectors. The Metropolitan is on this side, and then the Hancock is branched off on this side. These have got to be tight because you don't want them to be sucking air. Have all kinds of problems. Okay. Well, before we can do anything with the steam engine, I got to get some of this work out of the way. These are jobs that have piled up over the winter, and I got to get started on them. So I'll just show you a little bit about what's going on here. This first one is a 7 horsepower Galloway hit and miss engine, and that's a bore and sleeve job, plus the head work and some special problems here with the piston. It's got a cracked pin boss, so I'm going to bush the pin bores with a heavy bushing to try and save the piston. I've never done that before, but I think it should work. Also, the connecting rod has got to be cut a little bit and bored to fit the pin to take the slack out. The Babbitt is in really bad shape, but it's still in there. And some work done on the end of the rod, and recut this crack here so that it comes together a little bit more, and then ream it to fit the pin. And I got to make a new pin for this. This pin is pretty pitiful. And here's another hit and miss engine with quite a long cylinder. And this is basically just a bore and sleeve job. I think it's 22 inches long, the cylinder is. This is a Kawasaki 900, an old Z, and gonna bore it from 66 out to 70 millimeters. Big bore kit. We'll make a 1000 out of it. A lot of boring on that one. That's a Power Stroke diesel head. It was just a check and resurface job. That's already done. That's a 650 BSA 1966 model, and we decided that the bores were good enough on that to just give it a hone job to get the cylinder finish up and take any little small scratches out of it. So that's already done. These are small block Ford heads, 302, and they've already been through the cleaning process, through the baking oven at 670 degrees, and then through the steel shot blaster. And so now I'm grinding the seats. The valve guides are determined to be in really good shape, so nothing had to be done there. So I'm going to show you how I do the seats in my shop. I use a grinder, the 3-angled cutters that most systems use. I'm not really wild about because they just aren't accurate enough to get the concentricity on the valve guide that you can get when you grind them. Of course, grinding takes a lot of time. It's very slow. That's why nobody does it much anymore, but I do. So this is the way it's done. You got 3 angles that we're going to be concerned about. The 45, which is actually the valve seat, is cut on the valve at 45. And so you have a 45, and then you have a 30 degree that sort of chamfers the top, and a 60 degree that sort of chamfers the bottom. And in the process of doing that, you narrow the seat down to about 40 thousandths. I like a nice thin seat on the intake. And then check each valve to make sure that it's contacting all the way around and that the seat is in the right position on the face. So here's the 45, and I've already chewed it up in the dresser at exactly 45. I have an air tool here that spins it. The whole trick here is using just the right amount of pressure. Now I can see it hasn't cleaned up over on this side. There's still some pitting there. Now that's looking a lot better all the way around. Now the top angle is a 30 degrees, so this stone has been trued to 30 degrees. And this is the 60 degree. Chamfers the bottom of the seat. And finish it up with just a little hit on the 45 again. I'm going to take the camera down here and see if I can get this to focus. You can see I get it just right in the light. This is the 45, this is the 30, and this is the 60 down here. And you can see there's a couple of little pits left right here in the 45. Right there is the one. So it's got to go down a little bit further. Of course, that made the seat too wide, so we'll give it a shot with a 30. And the 60. This is a ball hone. It just puts a surface finish on the inside of the guides. This is a specialized surface grinder for doing automotive cylinder heads. It's got a 10-piece segmented stone under here, 10 stones set up, and there's also a socket in there for a fly cutter with a carbide tool for doing aluminum cylinder heads. So I've got the Ford head in here ready to go to resurface the gasket surface here. And this fixture is kind of clever. It's called a rollover fixture. It's a plate welded onto a piece of shaft here that pivots this way. If you wanted to do machine work on a lot of cylinder heads, like say in a regular milling machine like a Bridgeport or something, you could build something like this that grabs the cylinder heads by the manifold bolt holes and then you just have one jack here, and the slots on the plate are wide enough so that you can tap it up or down to level it, and of course run this up or down. So it makes a good way to hold the cylinder head, where a lot of times you don't have anything on the bottom that's straight with the top that you can like put some parallels across there or something. You got to put machinist jacks under all four corners. It's a real kind of a pain. So this rollover fixture would be a handy thing to have. Come across here with a file just to get any kind of nicks and burrs out of the fixture. And you got a stirrup precision level here, and run the jack up until it's straight that way. Tap it with a hammer, straight that way, tighten down the bolts. And I have a real precision level that I check it against when I get it close. And this one is so sensitive that if you get the bubble somewhere near the middle, it's way closer than you even really need it. Of course, when you tighten down the clamp on the jack, it changes it. And every once in a while, I'll put the level on a finished cut, because that's really all you care about. You want to be able to set up your next head in the machine level with the cut that the machine makes. So from time to time, the floor actually moves enough to throw this level off. And of course, in the spring when I start up, I check it a couple of times after the frost is gone out. Take a little skim cut to see where we're at. Make sure there's no surprises. Turn on a little cooler. Got to stop for a minute and put a little more coolant in my tank. I think it's running dry. This is the last pass across there. Probably taking a total of about maybe 6 or 7 thousandths off the surface. The idea is to take the absolute minimum required to get the warp out of it. Get the surface finish up where it should be. These new modern gaskets are what they call multi-layer. They're made out of layers of stainless steel foil and rubber, and they kind of give and take as the cylinder head expands and contracts over the top of the block, but they're pretty delicate, so you have to have a really good surface finish to make them last. This is right out of the parts washer. Ready to go together. The springs are all checked in the Rimac spring tester at the installed height. The installed spring heights are all checked like this. but you never know how many valve jobs these things have had. Okay, there they are, ready to go back to work. Finished pass for a Subaru. See this spot right here that we didn't clean up. Subarus get little warped spots, little low spots. They don't get warped over the whole length. This is a cylinder I'm doing for Mike Waller. It's a BSA V50. And he has a new old stock Heplite piston, oversized. And first thing we're going to do, measure the piston. 3-inch, 342. And we want 3/1000 clearance. So final bore size is going to be 3-inch, 345. This surface here is supposed to be perfectly parallel with this surface down here. So I'll mount this in here upside down using the base of the cylinder as a reference. That'll go up in there like that. There's a hydraulic jack here underneath that jacks this whole platform up to get the cylinder tight against the bottom of this plate. Just have to be careful to get the cylinder situated so that it pulls up against the plate evenly on the bottom, and then a little bit more pressure to hold it there. Now we're ready to center the machine up with the cylinder. These 3 centering pins, when I crank the screw on top, come out and center the whole machine on the center line of the cylinder. I'm going to run it down in there a little bit. Okay, so that's centered. And tighten it back up. I'm reshooting this little clip. Evidently the camera wasn't rolling when I did it before, so I wanted to show you how the cutter works on this Quickway boring bar. The cutter body has got a little spring-loaded cylinder here with a plunger, so that when you put it in the machine, it's got some spring to it. And the cutter goes in here like this, and you set it for approximately where you think you're going to need it. There's a lot of cut and try in this deal. Tighten it down with the set screws. There's actually a lapping disc on the top of the motor that has got a special jig for sharpening this at exactly specific 3 angles: the front angle, and the cutting angle, and the relief angle, and the top angle. There's actually 4 different surfaces that you're concerned with on this. So anyway, this goes in here like this, and it's got some spring to it. And you got a setting tool here with a hard carbide edge on the surface on the front, and this is set up with a micrometer that actually reads out the diameter that you're going to bore. So you set that for what you're trying to shoot for here. You slide it in until it clicks in place, and then I don't know if you can see, but the cutter is spring loaded out against this front face. So at that point you just tighten it down, and you're set for that diameter. And this machine will cut and repeat at less than 1,000. Pretty good old machine.
We do this in 3 cuts. The first cut is just a skim cut to get on through to check your alignment and make sure there's no surprises. The second cut is everything out to leaving about 8 to 10 thousandths for a finished cut. So this is the second cut.
Taking the last couple out of it with a hone, I'm down to about 1,000th here with coarse stones, and I just switched over to the finer stones. Tenths of a thousandth taper. That should do it. I got a 12-horse Kohler engine block in the works here for a customer, and I'm going to rebore the cylinder to a 30 oversized piston. But before I do that,
I'm going to grind the top of this straight with the bottom, because these get warped out of shape, and you use this surface as a index to set up the boring bar to bore the cylinder, and you can't, it's very hard, if not impossible, to get it to bore straight without decking this first. I found that from years of experience. So that's what I'm doing now. There's the setup. You can see how it's clamped down. That's probably about 15 thousandths off. So you can see what the problem was. It took 15 off to get it to clean up over here on this side. So this surface should be square with the base and straight with the bore. Okay, so here we are with the Kohler block in the Quickway boring rig, and I'm going to jack this up tight against this bottom plate. And one thing I do that I found helps is I put a piece of round stock under the block so that it can adjust the pressure evenly when you jack it up, so that it doesn't cock the cylinder in there, and it's in perfect contact at the top. So I got a little pressure against that now. I know it's a nice day. Quit looking out there. Pay attention to what you're doing. Oh, there it is, all three passes. The Quickway makes a very good surface finish. Does a really good job. That's ready to go to the honing cabinet. This is a John Deere turbo diesel in the rollover fixture to surface grind the gasket surface. Put it in the final rinse and put it together. The deal with remachining the valve surfaces on the Lively cylinder is that I can't quite figure out how they did it in the first place. I'm seeing some marks here that look like it was done with a planer down inside of this hole, but there's no way you can get a planer, or at least there's no way I can see that you can get a planer tool in there that will overrun the edge of this surface here and on the backside and clear this gasket surface lip here. Like I say, it looked like it was done with a shaper, but I don't see how they did it. What I've come up with is a face mill that will make it all the way over to the corner and still miss here. And a 2-inch one will just about do it. It's right up almost into this surface here. There's a little more clearance on this side, but the diameter of the face mill has to be such that more than half of it will overrun this edge so that it will clean out all the way to the corner. So what I've decided to try is this setup. Now this is an old R8 face mill arbor for Bridgeport that I cut down to 7/8 because 7/8 is the biggest collet size you can get in the Bridgeport, and I'm going to end up having to cut it off about there so that I'll get it down as close as possible with as little overhang. It looks like I'll have about that much overhang, which should be acceptable. If I run the cutter quite slow, I don't think it'll chatter. And then I can clean up this badly pitted surface here. But before I do that, I'm going to run this 3/8 end mill around the opening here to kind of cut it back just a little bit to give myself a little more clearance. There's plenty of room here for a gasket seal on this. And then I'm going to also machine this, as long as I'm set up here and I'm dialed in both in this axis and this axis. I'm going to remachine this surface here, just take enough off of there just to get it to clean up all the way around. It really probably doesn't need it, but it wouldn't make sense not to do it. So that's the plan. As you can see, the setup wasn't rigid enough and it was moving around and it was making it chatter here. And I believe it's because this piece of angle is not square. So there's not being held down. You can see that wasn't being held down tight against the table, so I cut some of it off. And I'm going to machine this surface square with this on the shaper. Now we'll chew these end plates up on the shaper. It's pretty fast. It's square now. I should have checked that. If you just naturally think that a piece of angle like that would be somewhere near square, that should make a difference. This is the second one. It's not your ordinary mill run extruded aluminum. This is very hard and very tough. It's probably 6061, probably T6. See, that did the trick. It's a lot more rigid setup. I'm going to just take about 1/8 of an inch off of this surface here and chew up the rough casting here. So I'll have clearance on my arbor to get out to the edge of this. Okay, now I think you can see the deal here. I've got to get up against this shoulder, and I have a little clearance here and a little clearance over here. I can pull past the center of the cutter past this edge, and the same down on the other side. So I think I'm ready to go. I'm going to skim a little cut off there, and if this setup works, I'm going to take the cutter back out and grind it so it's got a really nice edge on it, and do the finish cuts.
you enjoyed this conglomeration of clips from around the shop and getting some of this work done. Next video, we're going to get back under steam power again and do some serious work on the Lively steam engine components and do a large bore and sleeve job. Appreciate all the likes, comments, and subscriptions, and thanks for watching.